So on to part 3 of server who compute without a care. And here we'll be talking about, other services that belong to the compute category. So we talked about EC2, we talked about load balancing and auto scaling. And now I want to focus more on serverless, containerization, and also other tools. We'll get started with Lambda. So what is Lambda? And in Lambda, we're talking about serverless computing, whereby just think of it as a waiter in a restaurant. You only pay the waiter when you place an order. And if there are no orders, the waiter is not working. So similarly, with AWS Lambda, it only runs when you need it to run, and you only pay for the time when your function is running. So we talked about serverless. So that means that we have no servers to manage, unlike traditional servers. So EC2 is a server. And this is like, speaking of our restaurant analogy, we have a fixed number of chefs who are always cooking, whether the customers are there or not. And that means that you pay for the chefs time all the time, even if they are like quiet periods. And that means that if there's not traffic and your server is running, you still pay for it. But Lambda is more of a restaurant that calls in extra chefs when only a big groups arrives or something like that. So you don't have to keep paying for the extra staff when there are no orders. And this makes Lambda very efficient because it only runs when needed and scales automatically. So some of the key points, Lambda only runs when your code is triggered. So only runs your code when an event happens or a trigger happens. And with Lambda, I also mentioned you don't need to worry about provisioning your servers or managing any scaling. And it's very cost effective because you only pay for the execution time. So you are billed per the request and compute time. So what are some of the features and benefits of Lambda? First, pay per request. And this is like, streaming a movie on demand. You only pay for the duration you watch, that is the compute time, and the data you use, that is the request you make. So there are no upfront costs to install and maybe maintain a home theater system, that is a server. All of that is taken care of, and you scale up as needed when more people are watching. So Lambda pricing, pay per use model, you only pay for what you consume and nothing more. And a good example is, imagine if Netflix charges you only for the amount of content you watch and not like a monthly subscription or so. So similarly, Lambda will only charge you for the time that your function runs. With integration, Lambda works with various services, making it easy to automate our processes and also integrate our infrastructure. Also, we see it supports couple of programming languages, the Node.js, Python, Java, Ruby, and you can also create your custom runtimes if you need to. And finally, Lambda scales automatically, just like, streaming platform automatically adjusts its quality based on the viewer's internet speed. So without you needing to do anything. So it will automatically scale your applications in response to traffic that is coming in. So just an overview of how Lambda works. For example, here we have a serverless thumbnail generation creation use case, whereby we want anytime an image is uploaded to S3, AWS Lambda is triggered, Lambda generates a thumbnail and save it back to S3. So this is a simple, just a real world example of how Lambda helps automate a process. No need to maintain any servers to generate the thumbnails every time a new image is uploaded. So Lambda will do it automatically, saving you some time and money. So back to the console, I'll just show you my Lambda code. So I think it was in the Oregon region. Yep. So this is the Lambda trigger function. Just looking at it. So we set it up to be triggered by S3. So S3 is the trigger for our Lambda function. And if we look at this trigger and just check the details, there is this source bucket where anytime an object is created, so any post events, anytime an object is created within this S3 bucket, um, then a notification. So we have an S3 notification that happens, S3 notification event that triggers my Lambda function. So it's just that simple. So the source, the trigger is an S3 bucket. If we look at the code, so I had to install some libraries. So we have the Boto3, OSCs, and also the Python image library that we will be using to generate the thumbnail and so on. So we can see we download the object is created in this specific bucket. And once the image is resized, we want it to be uploaded to a bucket which is called resized. So this is the resized bucket. And if we go to S3, okay, so I have a couple of buckets over here. And in the Oregon region, I have the PJ source Lambda trigger bucket and the PJ source Lambda trigger bucket resized. So when an object is uploaded over here, Lambda automatically creates a thumbnail of that image and uploads it in the resized bucket from our function. And we also have a role attached to Lambda. So going back to Lambda, that allows it to put objects and get objects from the S3 bucket. Okay, so looking at the configuration and permissions, so we have this role attached to our Lambda function. Let's just take a look at it. Cool. So this is a customer managed policy, and you can see it allows integration with CloudWatch, so generating log events, creating log group, and creating a log stream. It also allows getting an object from Amazon S3 and allows putting an object to Amazon S3. So it needs to get the object once it's uploaded and put the object in the resized bucket. So we could be as granular as possible and specify the ARN of the source trigger bucket and the resized bucket over here if you need to. So let's try see how it works. So I'll go ahead to my S3 bucket, the source trigger bucket, and just upload an object in it. So I'll add files, which are images. And let's see. So I can add this thumbnail image, black and orange, and upload. Okay. So I have this black and orange live streaming YouTube thumbnail that was created. And if our Lambda function works correctly, and we go to the resized bucket, we can see that a new a resized object has been created over here, which is basically the thumbnail has been created. Okay, so that was on Lambda. And the other thing I would like to talk about is other compute services. So we have Beanstalk, a platform as a service. We discussed the service models in the first module on what is cloud computing, so you can revise that. But now think of it as a managed apartment building or so. So imagine Beanstalk as renting a fully managed apartment, in this case, in a large building. You only focus on your furniture, your decor, while the building owner, who is AWS, takes care of things like plumbing, security, electricity, and so on. So, and the infrastructure part. So the infrastructure like the EC2, the load balancing and scaling is taken care of by AWS. So the key differentiation over here is Elastic Beanstalk is a platform as a service, providing automated deployment and scaling with the flexibility to configure your resources as needed. So we can automate our deployment. It automates our deployment by managing all the other things like scaling, load balancing, health monitoring, and it supports couple of programming languages, the likes of Go, Java, .NET, Node.js, PHP, and so on. So that is Beanstalk, and the responsibility of the developer in this case is just to upload and manage the application code. The infrastructure part is handled by AWS. So EC2, infrastructure as a service, Beanstalk, platform as a service, and then we have the likes of Lambda, which is serverless. And then moving on, some other compute services that you need to know of when going into the exam is containerization tools. So I'm going to start with Docker. What is Docker basically? So this is a software dev platform that deploys applications in containers. And containers are portable and run consistently across any system. So some of the key advantages we have is no compatibility issues that we had before with servers, works with any language, operating system, and technology, and it's easier to maintain and deploy. So looking at some of the difference, what is the difference between maybe a container and a virtual machine? So think of it, just an analogy, think of it as an office and a shared workspace. So a virtual machine is like having your own private office. You get the whole space with its own operating system, but that means that the office requires lots of resources. So we have building, the whole building, which is the host operating system and the infrastructure. And inside the building, each one of us has their own office, and in their own office, you have your own resources over there. But Docker is like a shared co-working space. So we have an office over here, the whole building, but multiple people can share the same space, which is the you know, or host system or the co-working space. And this is more efficient because it requires fewer resources. So each person basically has their own desk in there, and that is like an application environment. So Docker containers are kind of more efficient than virtual machines because we are sharing resources with the host system. It's not like we have our own operating system. And containers are lightweight, making you able to run many containers on a single machine. Some of the concepts in containers, we have the concept of Docker images. And an image is just a blueprint of your Docker container. So a Docker image will contain your code, your dependencies, your libraries, and all your configurations that you need to run your app. And where are these images stored? So we can store our images in Docker Hub, which is a public repo where you can find any base images you want, like Ubuntu, MySQL, but you can have a private repository like the Amazon Elastic Container Registry. So this is a private repo for securely storing your Docker images, and it also has a public gallery if you want to share any public images. So Docker management in AWS or container management in AWS. So we have ECS, Elastic Container Service. This is AWS own container management platform where you run your Docker containers. And we have the EKS, Amazon Elastic Kubernetes Service. So this is used for orchestration, orchestrating containers at scale, and Kubernetes is open source. So orchestrating your containers, you go for EKS. We have the Fargate, which is a serverless container platform, and it works with both the Elastic Container Service and Elastic Kubernetes Service. So The only difference is Fargate is serverless, whereby it automatically manages the underlying infrastructure for you. And as I mentioned before, we have the Elastic Container Registry, whereby we store our Docker images. So this is a private repo to store your Docker images. So that's a high-level overview. Maybe in the cloud practitioner level, you only need to know the definitions of them. Maybe moving further into the course, you need to know how they work. So we have other services that can occur in the exam, like AWS Batch. And think of Batch as, just a factory production line. So each job in the line has a beginning and an end. And AWS Batch ensures that each job you have has the right tools and workspace to complete efficiently. So AWS Batch is a fully managed service for batch processing. A batch job has a beginning and an end. Yeah. So AWS Batch will manage everything in the background, things like scheduling your work shifts or providing the right equipment for each task. So ideal for running if you have up to 100,000 of compute heavy batch jobs, and they will launch either EC2 or spot instances as needed, and fully managed, so it automates the infrastructure so you can focus on your batch jobs or your workloads. Now, what is the difference between batch and AWS Lambda in this case? So batch is ideal for large compute intensive jobs, things like data processing, things like scientific simulations, things like media transcoding, where jobs may take hours or even days to complete. Unlike Lambda, which has a very short execution time. So Lambda is optimized for short event driven functions. So a trigger happens and that triggers our code to run. So Batch supports extensive workloads. It does not have any time constraints. You see, in Lambda, we have a limited execution time of a maximum of 15 minutes. So with Batch, you can handle more complex processing without worrying about timing out. So Lambda, you have predefined runtimes. It has a small temporary storage. It's serverless. Batch, no execution time limit. So as I mentioned, large compute-intensive jobs. It has a flexible runtime, supports larger storage options, and runs on EC2 instances for more control over your resources. And just to wrap this up, another service that you need to know of could be Lightsail. Think of Amazon Lightsail. I tend to think of it as AWS Lite. You see the way we have TikTok and TikTok Lite, or Instagram and Instagram Lite. So instead of renting a fully furnished, so it's like instead of renting a house and managing everything in it like EC2, here we are renting a fully furnished, apartment instead of building our own house. So everything you need is ready to go, all bundled together for your convenience, making it very easy for you to get started, even if you don't have deep cloud knowledge. So why Lightsail? Why would you use Lightsail? It's a great starting point for users who don't need the full customization of maybe our EC2 servers, but you still want a scalable cloud solution. And it's very useful for beginners or those who just want to host websites or applications without managing any extensive AWS configurations. So if you just take a look at the Lightsail console in a moment. Okay, so you can see how user-friendly it is. If you want to just create an instance, let's see what are the options you have. Nothing complicated like launching an EC2. So we see over here, you just choose your instance image. Do you want a Linux or a Microsoft Windows? And the operating, if you want some applications installed or just the operating system. So if you want the operating system only, you can select the operating system you want, CentOS, Ubuntu. If you want an application plus the operating system, maybe you want to quickly spin up a WordPress application or a Node.js or a Minstack, Django. You can have this installed together with the operating system and launched for you. So maybe I select the WordPress application. It has a default SSH key. You can change the SSH key if you want. Choose the network type that maybe has public IPv4 and public IPv6. You get details about the price per month. If you select, so depending on the memory you want, the virtual compute processing units, and so on. And give it a name and create an instance. So really easy, really quick for beginners, or if you just want to host a website without managing any extensive AWS configuration. That marks the end of compute without a care. We have seen a couple of compute options that we can use within the cloud. Yep. And in the next section, we get to storage within AWS. So thank you and see you in the next one.